Same direction, simplify. On top we have 4y minus 20. On the bottom we have 4y plus 12. Do we have, now remember that trick of simplifying the last problem only works when you have products in the numerator and denominator. Do we have only products in the numerator and denominator here? No, but what's the answer? So that we can simplify it, what could we do? So that we do have products. We're really good at making products now. We call it factoring, right? So the idea in these problems to simplify these problems, if they're possible to simplify, is to factor numerator and denominator. Factor everything. So what could you pull out of the numerator? So you get a 4 times what? Y minus 5. That's the numerator. And then you could also pull out a 4 in the denominator. What's left there? 4 times the quantity y plus 3. Everybody agree with that? Now, what can you divide out? Because the operation here and here is multiplication, you can divide out the 4s. Think about it. You could break up this. I don't want you to do it this way, but you could break it up to be 4 over 4, that's 1, times y minus 5 over y plus 3. That's the reason you can cancel out the 4s. 4 divided by 4 makes 1. It's division. So many students forget that. They think they can do this. Can you do this? Can you? No, that's the dark side. Don't turn to the dark side. Why can't you cross out those y's? It's not y. It's not y divided by y. Let's put it that way. It's the quantity y minus 5 divided by y plus 3. Are those the same? No. You can't get the same. If you take a number y, whatever it is, and subtract 5, it's not going to be the same if you take that same number y and add 3. You've got to divide out whole quantities. And so that you can't do. So the reason you can just cross these 4s out is the operation's multiplication, and you could separate this into a separate factor of 4 divided by 4, which equals 1. Okay? And then you're done. Well, rewrite it. Clean it up, rewrite it. Y minus 5. You can drop the parentheses now. The division bar is a grouping symbol, so you don't need the parentheses. Rewrite it, and don't cross out the y's. But so many students forget that, and some students in here will forget that. Some students in calculus forget that. It's the most common mistake in all of math, is to go like this. Oh, it makes no sense at all. If you had a number, if you assigned a number to y like 2, and you had 2 minus 5 and 2 plus 3 instead of y minus 5 and y, 3. Let me fix that. So let's say y were a number 2 instead of y. Would it make any sense to cancel these 2's? You wouldn't get the same thing, right? Okay, the division bar is a grouping symbol. You need to take that, that's negative 3, right? You need to add those together. That's 5. It's negative 3/5. But if you cancel out the 2's, do you get negative 3/5? You don't. And by the way, that's the way you can remind yourself of what's true, is to use numbers in place of the letters. You can see it can't be true. Okay, here we have a rational function, and I want to list the restrictions on the domain. So remember, the domain is all the values you're allowed to plug in, all the input values you're allowed to plug in the function. When you start taking ratios of polynomials, you have a problem with x values that create 0 in the denominator. So you have to restrict those values. So in other words, we have to figure out what x values will make 0 in the denominator. List all the domain restrictions on h of t equals t squared minus 3t minus 4 all over t squared plus 9t plus 8. So we don't want to end up plugging in a t value that gives us 0 in the denominator, because division by 0 is undefined. So how can we tell when the denominator is equal to 0? Couldn't we set it equal to 0? Yeah, in which case we'd have a polynomial equation. So we could get t squared plus 9t plus 8, set it equal to 0. We're essentially finding the domain, because when we find the t values that make that 0, those are the values we throw out. We say they're not in the domain. Everything else is. Okay, so this is a polynomial equation. How do we solve it? It's already set equal to 0, so what are you going to do? Reverse FOIL. So you get t here, t here. Two numbers whose product is 8 and whose sum is 9. Whoops, I put 9. I meant to put 8. 1 and 8, right? T plus 1, t plus 8, yeah? Set both factors equal to 0 and solve. You get t plus 1 is equal to 0, or t plus 8 is equal to 0. So what do you get? Yeah, but these are, you don't stop here. These are the values we have to restrict, right? List all domain restrictions. So t can't equal those values. These are the restrictions. Go t does not equal -1, and t does not equal -8. If you wanted to write down the domain, you would say all real numbers except t equals -1 and t equals -8. But you're just asked to list the restrictions, and so that's all you got to do. Does everybody understand why those don't work? You plug those back in, you get 0 in the denominator. That's it. That's what we're saying. If you plug them into the formula. Any questions on that?